breakdown.
Thanks a lot. I'm Michael and I like games. I'm from infrastructure team in Seznam. And besides of game, I like drugs. Especially tea. So usually it's mine. These are mind drugs, not just drugs. So let's talk about some mind games. I believe that most of you know this sentence. And this sentence is in a presentation that we show to every developer that is coming to Seznam. And I think it's really important. They should know what they are going to do in future. I will speak about the game that we play in Seznam every 2 weeks. I will let you know why we play the game, how we play the game, how we fail usually, and what we learn from the game. So it will be quite simple. So let's start about why we play the game. Seznam has quite big infrastructure. The infrastructure is built by Seznam and in quite small team. It has advantages and disadvantages. The big advantage is that we build it by ourselves. The big disadvantage is that we build it by ourselves. So we found that simply the important stuff is that the infrastructure should be as simple as possible because we are a company that needs to produce money. The infrastructure has to be as cheap as possible and it has some consequences. So basically we have 3 data centers. Every data center is hardware which is built by ourselves. And the hardware is unreliable, so we know that the hardware will fail. And on the top of the hardware is built something which we call CIF, which is cloud infrastructure, private cloud. And on top of the systems are the applications from Seznam, and Seznam built a lot of applications which are somehow connected to each other. And the system is really complex, and it's not so simple to test the system. There was the idea in the beginning that Seznam will build something which was called like a small Seznam. There should be infrastructure as in the production, but finally we found that it's not possible to build it because it's a really complex task. So basically, the result is that if you want to test the system, you need to test it in production. So basically, that's one of the outcome that we found. And the history of the game is really old. It was like, I don't know, maybe 7, maybe 8 years ago. But finally, in last year, we really start to do it in the way that it's done like every 2 weeks. Before, it was done like once per month, in the beginning maybe once per year, and it was, I would say, terrible experience. I will let you know why. But what you should at this moment know is that simply the infrastructure of Seznam is interesting in the way that we have 3 data centers. We have hardware which is built by ourselves. We have a private cloud. And we believe that it makes sense to test the stuff in the system in the way that we simply switch off part of the systems and test whether the system is still working or not. And we are trying to build a system in the way that every developer should know that every like a virtual machine, every machine can fail, every availability zone can fail, and every data center can fail. They should build the system this way. Next, why we do it? Another reason is the cost. If you imagine that we have, I don't know exactly, but it could be something like 16,000 of machines. free data centers and many people that are working on the systems, so it costs a lot. Additionally, if there is a fail, for example, if there is a outage in Seznam, it costs again a lot of money, and because of this, the system should be reliable. The question is how to build a system in cheap way and reliable. It's possible, but you need to simply be quite creative, and we are creative. So basically, one of the reasons why we do it this way is the money, and I believe Seznam is able to build the application that is building right now because of the infrastructure, because most of the applications are really not possible to build in the public cloud because it would be too expensive. And the last reason why we do it this way is, from my point of view, maybe even most important, because I believe that treasure of every company are people, and they should know what should be done if there is some problematic situation or if there is a problem. Additionally, they should feel safe. So, for example, if I think everybody in this room has or had some issue with, let's say, in production, and you know what does it mean if there is an issue in production, and I believe that we should somehow prepare the people for the issues. And the result is that if there is a real problem in the production, the people know what they should do, and they are not stressed so much. So basically, I believe this is one of the most important result. And I believe simply that your job should be safe place, and this is one of the stuff that simply help with this. So how we test it? The test is done in these days every 2 weeks. It's automated. It's automated in different levels. The first level is that the network disconnection and connection is automated with scripts. Additionally, the cloud infrastructure is automated in the way that simply if the data center is switched off, all the services that are in the cloud infrastructure should be able to resolve it, and all the applications that are built on the cloud infrastructure should be also able to resolve it. Then we rotate the data centers. So basically, we know that because we have 3 data centers, so in every 2 months, at least one data center, every data center is tested. And this is important from the a complexity point of view, because the Seznam system is live, so we have hundreds of developers that are developing different type of applications, and they are deploying the applications, and the changes in different time. And simply, what we found is that the system is changing almost every week, and because of this, simply you never know the state, and that's why it makes sense to test it frequently. Because if you don't test it frequently, then once you test it, let's say after half of a year, you will find issues that you don't want to find. So how we test how we play the game? This is a simplified diagram of the Seznam network. You can see that we have 3 data centers. Important point is that we have 2 lines to every data centers from every data center, and we have 2 connections to external network to internet. So it looks quite simple, but if you look to the next diagram, you will see that it's not so simple. So here is again simplified diagram, but this diagram contains the connections in the data center and the connections between data centers. So basically, in every data centers, we have more networks, not just one network. There is a managed network, there is a VPN, and so if you do the cut of the data center, you need to do it in some way. You cannot just cut everything. Uh, 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 Another important point is that simply if we do the cut, the data center is the data center which is not in the part which is not part of the system is still living. So inside the connections are working, but outside the data center cannot communicate. We already tested how it looks like if the network in the data center is not working completely. But you don't want to do it. So basically, this is not what we want to test, but we already tested. The common test works the way that simply the person that is working on the cut, usually some network guy, will start the script, and the script is cutting one line by line. It's done line by line because in the beginning we thought that we will do it as probably it will happen if there will be some, let's say, real issue. For example, I don't know, one data center will be destroyed. And we disconnected all these lines in one shot. What happened was that the tables that are in the switch in the edge routers were full of the BGPs sessions, and then the BGP sessions should be connected once again. And simply it took quite long time to connect back the lines. And simply this is not what you would like to test every, let's say, 2 weeks or every month. So we decided to do it line by line, and it works the right way. The only point what is important that you should disconnect the data center that was announced that should be disconnected. We already found that it's possible to disconnect different data center. And it was not a good idea, but the future will be that we will do it in future even like randomly. But in these days, it's done the way that we announce which data center should be disconnected, and we are disconnecting the data center. So what is the result, what we found? We found that almost everything can fail. We have some reports from the outages, and if you look to the reports, every outage has some issue. What is the nice point that usually the issues are in the standard outages, it's quite small, but the issues are there, and they are there because really the systems is changing. So you need to know that simply something will fail. Additionally, there is a procedure that simply if system is failing, the team is usually trying to resolve the system. If the team found that they are not able to resolve it, then they discuss it usually with the developer leader of the unit, whether it's a real issue or not. Because, for example, it's different if, let's say, homepage of the system is not working, or if, for example, something like, I don't know, astrology page is not working. So there are differences in the system, and there are differences in the impact of the cost, and based on this we make a decision, or the developer leader with somebody who is leading the outage makes a decision whether it makes sense to continue or not. And it's common that in some situation we simply stop the outage, and we will simply roll back everything, and we start to work again with the free data centers. What are the common issues? The common issues are that there is a performance issue because simply the application by itself is not scaled, or another problem is that the applications which are dependent on the main application are not scaled. Even infrastructure doesn't need to be scaled in some situations, so this is one of the issue. Another common issue is some misconfiguration, so basically the developer put there some bad configuration. For example, the system is not, the service is not cross-clustered. One of the another common issue is the synchronization and the replication. For example, if you connect back the system, if the data center is cut off and then you join the data center back, the systems that are receiving the data should synchronize the data to the other data center, and even some system from the data center which is cut off needs to synchronize the system back, for example, I don't know, monitoring system. So this is another common issue. And the biggest, I would say, issues that we found were related to databases. So one of the, I think, story that we have, let's say, I don't know, 2 years ago was that when we switched off the network or the data center, tens of the MySQL cluster were not able to find the master, and because of this, the databases were not able to receive the writes, and simply the applications were not able to. Many applications were not able to continue, and it was not so simple because. If you need to find or resolve the issue in the database cluster, if you don't have a master, it's not something that you can easily automate. So it took some time to resolve it back. Then another interesting issue, maybe issues, are with the load balancer. We have a custom load balancer which is distributed, and we developed the load balancer by ourselves. And common issues that we found in a history was that the load balancer has like a 2 level. One level is nodes which are on the L3 network level, and another level is L7 level. And on both levels you could have a problem with performance. So we found that, for example, part of the load balancer was not able to handle the traffic, and this has usually quite high impact because then part of the applications are not able to work. So basically, if something like this is happening, we are usually switching back the data center and we are trying to find how to scale up the load balancer. Another interesting story was related to the registry, to container registry, and the issue was that once the data center was cut off, the other data centers needs to scale up the systems, and they start to scale up the system, and they simply shut down the container registry, and we were not able to scale up. So this was another interesting story, and the biggest story that we had was related to DNS, and the story was related to internal DDoS. Simply, there was an application that in the data center that was switched off was querying the DNS, and it started to query the DNS in a rate that was not possible to handle. So in the data center that was cut off, the DNS system was down, and we didn't know it. And once we connect the data center back, the data center destroyed the other data centers. So it was really, there was like a several hours outage. It was the biggest outage that I saw in a Seznam, in a history when I was in a Seznam. And it was some consequences because we really tried to do the outage a little bit in different way. And I would say that the biggest positive outcome is that if you cut off the data center, you still need to look into the data center and you need to check what is going inside, because if you join it back, simply you could have really impact that you don't want to see. So these are the issues, and the issues that are really like issues are happening frequently, but most of them are usually small. And what is the outcome? From my point of view, the biggest outcome is that you should think about the errors, that the errors are some of like a stuff which is happening in like a life every day. And I believe that our culture is a little bit strange in a way. I believe in Czech culture, maybe in different culture it's different, that we believe the error is a real problem and it should never happen. The problem is that the errors are happening every day and everywhere, and simply I think we should change it in a way that simply errors are here, it's common, and we should learn something from the errors, but we should not try to not do errors. So this is the result, and the common solution how to handle with this is something which is called postmortem. I believe most of them, or most of you know this, and basically the idea is that if there is an issue, you should not try to find who is responsible for the issue, you should try to find how to resolve it. And so my usual answer is that for me it's not a problem if there is an issue. For me it's a problem if the issue is still repeating and we don't care about the resolution. That's the outcome. Another important outcome is that you need the rules, because if the system is complex, you need to define some rules, how the system should be developed and how it should be handled. And the rules should be tested, because if you don't test the rules, nobody will care about them. So you need to find some solution how to test the rules. And the last outcome are related to people. Again, I think that this is the most important stuff that you should care about. And I believe that it makes sense to stress from time to time the people, and but stress them in a way that they know that they will be stressed. And I think that it should be compared, it can be compared with something like a file drill test, or if you ever see firemen, how they do the testing. They do it in a way that they have some common scenarios or common procedures, and they simply test the common procedures. And it's not connected with the reality, it's connected with some like a virtual scenario, but the result is that they know what to do if something is happening in reality, and they are prepared and they know how to communicate, and they are not in a big stress because they know that simply it's common and it's happening. So this is another important point, and I believe that the people works in a different way than without these testing. And what is the plan? What we would like to do in future? We would like to randomize the test. So in fact, it's happening if somebody make a mistake, but we would like to make it regularly. So basically, it should be common that. And interesting point was that I think 1 month ago I have a questions to the developer leaders whether they agree with the randomization, and just one of the developer leader told me that he is not prepared for this, the others are already prepared. So I believe that it's not so big deal and we should be able to do it. Another change that we would like to do, the test in different levels, not just on the data center level. We would like to modify the cloud. I mean, just safe to randomly kill the virtual machines in OpenStack and in Kubernetes. In fact, we already do it because we have the hardware that is from time to time crashing. But simply, we want to do it really in a regular way. We cannot do it in all tiers, but there is already agreement that we can start with this in one tier and we'll continue with other tiers. We should continue even on network level. In fact, for example, load balancer already started the test that they switched off the load balancer in one locality, and because the application has to be cross locality, there is not big impact, but the test is just started, but basically we will start even on the network level. And even the network engineers plan some tests that they will, for example, switch some switches or edge routers, and they will test what will be the impact. Another change which is already happening is related to recovery. So all the services should prepare some plans for the recovery, and they should do some testing with the recovery. So this is already happening. And then I think what we should do additionally, we should change some kind of planning of the test, because what is the result right now? That if you imagine like a big complex system, there are still happening some like updates. Then we do the testing, and I have the feedback from the developers that they are somehow missing the dates. They don't know, in fact, whether there will be, when will be the upgrade, when will be the test, and we should try to somehow aggregate and prepare for them some system where they could see what is happening in right now, and they should plan the task. So basically, we should somehow aggregate the test. We should prepare some like a longer plan, and I believe that we should somehow even work on the culture. I mean, of the what I said before, like the culture where the error or the issue is not a problem. So that's it. And that's all. So thanks a lot for your time. I'm sorry for boring and long presentation, and do you have some questions?
Hello, Radek Zajíc. I have a question. Complex systems often have complex dependencies, like a system A depending on system B, and system B depending on system C, and sometimes system C depending on system A, creating circular dependency. Have you encountered like weird dependencies, or have you uncovered using these tests some of those weird dependencies that might have created significant outages?
Yeah. For example, the load balancer has MySQL. The MySQL was load balanced by the load balancer, so that was one of the tests. I think maybe more important for these like mind games is the recovery, because if you try to recovery, you need to have a you need to find a system that should be alive. So I believe for the like a Silker dependency test is more interesting to think to start to play the game with the recoveries. But even with the data center test, you will find some, but usually the tests are related to whether the dependent system is cross-balanced or not, because basically what is happening that some of the system is not cross-balanced, and if you switched one of the data center, then it will fail. So this is what you will commonly find. But even you can find some silkers. So yes, this is happening, and you are right.
Okay, Jan Panáček, this is a bit off the point. It was just a notion, but you mentioned you have in-house built load balancer. Mm-hmm. I have 4 questions. All of them are why. When does finite amount of vanishes just stop scaling because you scare me? Thank you.
We have originally some load balancer from F5 system. The problem with this load balancer was that it was not so simple to scale it up, because simply you need to scale the hardware, and it cost a lot. So that's why we decided that we would like to develop some like a software distributed balancer. So this was the reason, it was the cost of the balancing. In fact, I believe that it has some other advantages in these days, because we are able to change the stuff that you cannot do on standard load balancers. So for example, if the war in Ukraine started, there was a really big DDoS attacks to Seznam, and we were able to modify BPF filters on the balancers to simply cut it off. We would not able to do it on, let's say, F5 system. Additionally, for example, we are easily able to add their logic to that is related to cookies. So, for example, we are able in the load balancer to start like a small script, small Lua scripts that are able to modify the headers, and they are like a more like a logic which is in effect in the load balancer. So I believe it makes sense. Mainly from the scalability and additionally from the like a usability point of view. But that's just our story. You know, the Seznam story is that Seznam is trying to build many stuff by itself, and Seznam is doing it with a really small amount of people. Every team has just, I don't know, 4 or 5 people. They are usually doing several stuff. And the result is that you do a lot with small amount of people, and it has some advantages and disadvantages. Yeah, so that's the common solution in Seznam. So what I say to everybody who is coming to Seznam, if you like adventure, this is one of the best places that you can be. And it has, the adventure has like the many different meanings, and I believe that all of the meanings you can find in Seznam. So that's it.
Honza Molnar, what is the day of the week when you are playing the games to know you are just playing the games and the system is not broken?
Yeah, it really happens that simply the if you play the game, Seznam could be broken. I was a few times on a management board just to explain what happened. And I would say that the result is that they understand that it makes sense, because what simply I try to explain to everybody is that simply these are the outages that we can plan. If we don't test it, and if we don't do the like exercise, we will find the outages that we simply don't want to see. And in situation when the people are not on board, for example, imagine that it's Saturday, something like this is happening, you need to find the DevOps people, you need to find the developers, and it will take a lot of time. So the result in these days is that even the management board accepted, they agree that it makes sense to do it. You are right, that from time to time they say there will be no outages, you should not do it in this day because we need to do something. So we have from time to time, or we need to from time to time change the outage test date from different reasons. But basically we have outages that are related to this. But the culture is changed in a way that simply they agree that it makes sense and they like it. That simply, and especially developers like it, because they find many issues that they would not be able to find it without this. They would find it in like a real outage, and simply you don't want to find it in real outage. So that's it. So I'm not sure whether I answered the question in the right way. Is it? Yeah, okay. So is there any other question?
If not, we will have a break and we will continue on 7:15. Oh, sorry. Yeah, 7:15. Hello? If, should you can sit down again, it would be great. Because we've got some more speakers and we would like to continue.
Ne, dobrý, já nepotřebuji. Teda ty taky nevím, proč ho máš.
Hello? Could we continue? Please. Zito, beer you say? Beer? So, without further ado, let's continue with Mikhail and his talk about how they are teaming the complexities in Aki. Thank you.
Okay. Hello, everyone. My name is Mihailo, and I work as Android developer at Eki. And today I would like to show you how to tame complexities using delegation. As a disclaimer, I would like to say that while this talk is based on Kotlin and Android, because that's what I mostly do, but it's really language agnostic. So the things I'm going to be talking about can be applied to any language that has some kind of reactive streams. So in Kotlin, we call those flows. But if you're using Java, you have the RxJava to help you. And if you're using Swift, you've got the combine. And the concepts and approaches from this talk apply to you as well. So to start, let me clarify what I mean when I say complexities. Imagine that we are implementing a video streaming application. And to start, we'll have just a basic video player with nothing else. It's very simple, it just plays videos, but let's be honest, it's not really useful in this state. So let's add some kind of overlay for controlling the video. So that's already much better because our users know what they're actually watching because there is a title there to help them. And they can also play or pause the video. And there is also a sig bar below, so they can sig in the video. Okay, but then the product team comes to you and they tell you that users really like watching TV shows, but they don't like watching the intro that every episode has in the beginning of the episode. So they ask you to add the skip intro button. Okay, let's put it there. But then the product team comes back again and they say that they would like to improve the user retention and that they would also like to keep users in the player for a longer time. So we need to introduce some kind of autoplay feature so that when user is close to finishing the current episode or movie, we suggest to them the next episode or the next movie that they can watch. Okay, let's say we somehow add that to our player, but then the product team is back again, and this time we need to show the age rating for the movie at some points in the video, and also sometimes we need to show content tags, which are, you know, like violence, references to drugs. You need to show those things sometimes in the video. And I think you already see where this is going, because this was only a small part of the features that we need to implement in the player. There's actually a lot more. There are like UX features, there are a lot of analytical stuff. And how do we handle all of this? Well, to begin, let's talk about architectures a little bit. So on Android, we commonly use MVVM, and same applies to iOS. I'm guessing most of you would know what MVVM is, but if not, I'll just go through it briefly. It stands for model view model. We have the view model where we store the state, and the view is observing that view model and is reacting to changes. And the view is also able to call some kind of actions on the view model, and then the view model updates its internal state, and the view gets the new state because it's observing it. On Android, the view is typically written in Compose, And because of how Compose works, the best practice is to expose a single observable object from the view model. And this might not be the case for other platforms like iOS, but in this talk it doesn't really matter, and what I say next still applies. So this is what the screen state can typically look like. This is just a simple example where we have a title and some kind of items that we want to show on the screen. So now let's try to model our player state in a similar way. So we start by adding fields from the overlay. We've got there the title, which we'll show to the user. We also have the flag if the video is playing to show correctly the play or pause button. We have some stuff for the seek bar like current progress and total duration. And now let's add fields for the skip intro feature. So we need to show or hide it correctly at the correct points in the video. We can also put it to correct position on the screen because it can be on the left or on the right, depending on some conditions. And then we also right away add the data for the autoplay feature. So we also have, if it's visible or not, the title, the options that user can select, and the countdown until the autoplay will get dismissed automatically. And we still need to add the age rating, so let's throw that in as well. And this is still just a small set of features, and you can already see that the object is getting really, really huge. And on top of that, somewhere in that view model, we'll actually need to create this huge object. So there will be a very long function which will be creating this. And also the view model will need to handle all the actions that user can take on the screen. And there are a lot of those. So what we are getting is a really bloated view model, which will easily have over 1,000 lines of code. And it will be really hard to extend, because every time you'll want to add something to it, you'll have to come back to this terrible class, which no one really wants to see anymore, which has 1,000 lines of code. And don't even ask me about testing this thing, because it's really not going to be pretty. So what do? Is there some smarter way to do it, which will be easy to test, maintain, and extend with more features? Well, sure, that's why I'm here today giving this talk. And the answer to this problem is some smarter architecture using delegates. But until we get there, there are still a few steps that we need to take. And the first one would be to get rid of that huge state object. And we can do that using state decomposition. To decompose a state, we need to first identify the independent feature inside of our player in our case, and identify the substates for each of those features. Then we take those substates and create a separate class for each of them. And then we create the final screen state by combining those smaller substates using nesting. I'll show you an example and it will be clear after that. So let's take another look at our player. If you think about it really carefully, then you will see that the overlay is actually independent and we can handle it completely separately from other features. And we can model it something like this. This is here Kotlin's SILT interface. This is equivalent to enum in Swift. So we model it in a way that it can be either hidden or visible. And if it's visible, we pass the data that we need to show to the user. Again, title, if it's playing, and some stuff for the seek bar. And another independent part would be that skip intro feature, which we can model in a very similar way. It can also be hidden or visible. And if it's visible, we pass there where to show this thing on the screen. And we keep doing the same thing for other features like autoplay, age rating, and others that we might have. And we end up with a final screen state that looks something like this. And this is already much nicer than before, right? And now that we have our state class sorted out, we need to talk about different approaches of creating the state and later updating it. The classic non-reactive approach would be to have the state stored in some variable or stream as a single thing. And when we want to update it, we would take it out, change some fields inside of it, and then emit the new state. And in Kotlin, it would look something like this. Here we have a function onPause, so it's reacting to user pressing the pause button. And we assume that the screen state stores the current screen state, and this dot value call just gives us access to the value in the stream. And here, since user wants to pause the player, we just update the screen by copying the old value but setting the isPlaying flag to true. Okay, but this assumes flat structure for the screen state, and we've already seen that it's not really the best thing to do. So for us, it would look more like this. And this is already not very nice. And this approach is pretty hard to write when you're using nested states. And in my opinion, it doesn't even make much sense, because why would you need to access the whole screen state and mutate it in some strange ways maybe, when you just wanted to change a single independent thing on the screen. And that's where the reactive way comes in to save us. So instead of having a complete state stored somewhere, we instead need to find some, let's say, core states, which are just the smallest state variables that you've got on the screen, and which you can use to later combine them into everything else you've got on the screen. Let me show you an example. We have our video overlay. And if we think about it, actually everything that we need is the metadata of the video, the current progress, and whether the video is playing. So from the metadata, we can get the title and the duration. The position is something we need to keep updating, and whether it's playing as well. And everything else can be just created by combining those three things. And the greatest thing about it is that now to update the state, you just update the appropriate state variable, and that's it. And the combination logic then takes care of the rest. And the combination logic might look something like this. This is just a very simple example, but it can also be much more complex. You can use everything that reactive streams offer, like filters, maps, transforms, whatever you need. And why I also like the reactive approach is that when you later look at this class, you see exactly what the screen state consists of, and you see exactly how the final thing is created, which is really nice. Let's now apply this approach to our player and see where we get from there. On the screen, you can see a few of our core states on top. I didn't put there all of them because there isn't space for that. So we got the metadata and whether your video is playing for the overlay. And on the right, we've got the position for skip intro and our position in the video. And we can use those and combine them into the full video overlay state and the skip intro state, which we can then use to combine into the final screen state. And then when the user performs some kind of action and we want to update the state, we simply change one of the core states on top, and then the change will automatically get propagated to the overlay state level and then to the final screen state. And that's pretty nice, right? And yeah, if you look at this diagram really carefully, you'll see that there are actually two completely independent parts there for the overlay and for the skip intro. And what if we take those parts and actually put them to some kind of black boxes, let's say, and then we'll delegate all the logic related to those features to those black boxes. Well, that's exactly our goal today, so let's see how those delegates would look like in more detail. As I've already said, a delegate is basically a black box that handles some feature. It has separate interface for actions, that's how it gets its input, and it produces a single state as an output. To show you an example, this is how the actions for the video overlay might look like. I've listed only a few of those. There is on play, on pause to react to users' actions on that button, and also on screen tap. This is to show the overlay or hide it when user presses the screen. And this would be the body of this delegate. There would also be some kind of reactive internal screen state, which I didn't put there because there wasn't space for that. There is also implementation of those actions where you would change the state in the way that you need. And we also have the video overlay state, which is the output of this delegate. And now we get to a really, really interesting part, and this is our view model. So the view model should have its own actions interface, which just inherits from all sub-interfaces for actions, from basically all interfaces of those delegates. As you see on the screen, we got player actions, which inherits from video overlay actions, skip intro. There would also be like the autoplay, age rating, and so on. And this way, this player actions interface will have like all the methods from the screen. And then coming to the body of the view model, we can see some Kotlin magic in action here. And by magic, I mean the by keyword. Let me explain. So here we inject our delegates to the constructor, and we let our view model implement the player actions, so it's like top-level interface. But we also let it implement each of the sub-interfaces, like each interface of the delegates, and we delegate its implementation to the delegate which we've injected in the constructor. And then we create the screen state by combining the substates from the delegate. And this is like everything. I haven't really skipped or shortened anything in here. This is everything that we need, and we are just delegating all the logic to other classes. So let's summarize what we've achieved here by this architecture. We've got a really small and concise view model, which only coordinates the delegates and isn't really adding any more logic on top of that. It is really easy to extend with more features, because if you need to add something else, you just create a new delegate, you create a new interface, and you somehow add it to the final screen state. It's highly testable, since you can test each of the delegates separately. And as a bonus, the delegates can actually be polymorphic. And what I mean is you can create an interface for some delegate and put their different implementations. And we are actually using that for the player overlay, because when we have the live stream and non-live stream, they have pretty different logic for how you display the overlay. So we are doing that with polymorphic delegates, but this is out of scope of today's talk because we are running out of time. And that'll be all from me today. I highly recommend you to try out this architecture on your projects, and thank you for your attention.
So, any questions? Really? Ah, Radek.
So this looks like a well thought through architecture, but it looks like there was a bumpy road to it. How many iterations did you have to go through to like end up with this architecture that you are happy with? It looks like there was a lot of lessons that we have learned, and I would like to learn how did you get there. Thank you.
Yeah, thank you for the question. This is actually a very simplified version of what we are really doing. It's like we are using even more layers of those delegates, and it's more complex than that. And unfortunately, I didn't have the time to show all the solutions for the harder problems that we faced. But I would say this is probably the first iteration of this thing, actually, and it's working pretty well. Because, yeah, we face some issues, but there is always a way to resolve them, and it still looks pretty good. Because we are doing like a huge player based on this with like a million of features, and so far it's holding pretty well.
Anyone? If no, really? So that's it for YouTube stream, because the last talk, there will be some nasty details, I guess, and it cannot be streamed online. So it's good for you that you appeared here today. I've seen that few guys are online, but they aren't asking the questions. So we will continue offline without YouTube, and Hopefully you will join in person next time. And let's continue at 8.